Every automaker on Earth is playing by the same rulebook right now. To make an electric car go far, you strap on 400 to 600 kilograms of battery. Then you pray the charging network near you actually works. That's the deal. That's the only deal on the table. Unless you're Mazda. Mazda just looked at that rulebook and said, no. Instead of chasing bigger batteries, they dusted off an engine everyone assumed was dead. The rotary. Yes, the same rotary that Mazda officially killed back in 2012 for being thirsty and fragile. Except this time, it's not spinning the wheels, it's quietly generating electricity, turning your car into something that drives like an EV but refuels at any gas station on the planet. Think about that for a second. While Tesla, Ford, and half the industry are locked in an arms race to cram more lithium into ever heavier packs, Mazda went the other direction entirely. They took an engine most people had already written an obituary for and gave it a second job it might actually be perfect for. Is this genius? Is this Mazda finally admitting they're too small to build real batteries? Or is this just nostalgia dressed up as innovation? Stick around, because by the end of this video, you might find yourself questioning whether the rest of the industry has been relying too heavily on one solution all along.
Why a triangle beats a piston? To understand why Mazda is betting its future on this engine, you need to understand what makes it strange in the first place. A normal engine works like a runner, pistons slamming up and down, thousands of times a minute. Every one of those pistons has to stop completely, reverse direction, and accelerate again, over and over. All that starting and stopping creates vibration, and taming it requires a heavy, bulky block full of counterweights and balance shafts just to keep the whole thing from shaking itself apart. There's also a camshaft, a valve train, timing chains, a small city of moving parts, all built around the basic problem of controlling that violent up and down motion. The rotary engine doesn't run like that at all. It spins. No pistons, no camshaft, no valves. A curved triangular rotor turns continuously inside an oval-shaped housing, and each of its three faces completes a combustion cycle during one full rotor revolution. Because the output shaft turns 3 times for every rotor revolution, a single rotor produces one power event per shaft revolution. Its real advantage isn't a magical combustion count, it's the compact size, smooth rotation, and ability to produce serious output from a remarkably small package. There are fewer moving parts and none of the violent direction changes found in a piston engine, although sealing, heat loss, and the rotary's long combustion chamber still create efficiency challenges of their own. Think of it as the difference between a sprinter and a figure skater. One is constantly changing direction, burning energy just to stop and start again. The other glides in one continuous motion, never fighting itself, never wasting energy reversing course. And the payoff is real, not theoretical. Mazda proved this decades ago with the RX-7, a twin-rotor engine that weighed roughly 100 kilograms in some configurations and still produced around 250 horsepower. Its advantage wasn't that no piston engine could ever match the number. It was that Mazda could generate sports car power from an engine physically far smaller than most alternatives of its era. For a company trying to build an electric powertrain without a massive battery pack dragging down the whole vehicle, that kind of compact, lightweight muscle is exactly what you need. It's the missing puzzle piece that makes everything else in this story possible.
The trick: a gas station EV. So how does this actually work in a real car? Meet the MX-30 REV, a series plug-in hybrid built around the extended range electric concept. Here's the honest version, no marketing spin. At the wheels, it behaves like an electric car. Technically, it's a series plug-in hybrid. The wheels are turned entirely by an electric motor 100% of the time. There is no gearbox connecting the engine to the wheels, no clutch, none of the traditional hardware you'd expect from a hybrid. But instead of stopping at a charger every few hundred kilometers, it carries its own tiny gas-powered generator on board. An 830cc single-rotor engine
just 75 horsepower on its own, sits under the hood with zero mechanical connection to the wheels. It never drives the car directly. Its only job, its entire purpose, is to make electricity and feed it to the battery. Picture your smartphone, a great battery, but you're always hunting for an outlet by the end of the day. Now imagine that phone came with a built-in power bank that quietly tops up the battery whenever it dips low without you ever having to think about it. That's essentially the MX-30 REV. You drive electric, silent and smooth for your daily commute. When the battery gets low, the rotary engine wakes up in the background, operates within a much narrower and more efficient RPM range than a conventional propulsion engine, and generates electricity for the battery and motor. No drama, no range anxiety, and critically, no jarring transition through the drivetrain. And that narrower operating window is the real engineering unlock, the thing that gives Mazda a credible path to solving the rotary's decades-old reputation problem. Old rotary engines, like the one in the beloved RX-8, got a bad reputation because they were pushed hard across a wide, constantly shifting range of speeds, accelerating, cruising, redlining, which chewed through fuel and put enormous stress on the apex seals, the small components sealing each combustion chamber against the housing. Drivers loved how they revved, but hated how often they needed rebuilding. As a generator, this engine no longer has to cover every condition required to drive the wheels directly. Its speed still changes with power demand, but Mazda can keep it inside a much tighter operating window. That removes several of the harsh conditions that damaged the rotary's reputation. Combined with redesigned seals, new materials, direct injection, and a gasoline particulate filter to clean up emissions, none of these are flashy headline features. They're the unglamorous, unsexy engineering work that turns an old idea into a reliable modern component. The result? A 17.8 kilowatt-hour battery paired with a 50-liter fuel tank, delivering more than 400 miles of combined range, depending on specification and test cycle. That's not a compromise you settle for. That's a genuinely competitive number that rivals plenty of pure combustion vehicles on the market today.
The honest trade-offs. Now, let's not pretend this system is perfect because it isn't, and any honest analysis has to look at the downsides just as hard as the strengths. If you never plug in and let the rotary engine do all the heavy lifting, fuel economy drops to somewhere between 29 and 33 US miles per gallon, basically what you'd get from a mid-sized gas-powered SUV. That's not impressive by any modern standard, and if you're driving cross-country every week with the battery mostly ignored, you're simply not getting the environmental or cost benefit this whole system is built around. This car is designed to be plugged in. Treat it like a normal gas car and you lose most of the point. DC fast charging is also limited, just 36 kilowatts, meaning a 20 to 80% charge takes about 25 minutes at a fast charger. Compared to the fast-charging EVs launching in 2025 and 2026, many of which can hit that same charge level under 15 minutes, that's noticeably behind the curve. And then there's the MX-30 itself as a physical package. Clamshell rear doors that only open once the front doors are already open, a cargo area of just 350 liters. This is not a spacious family hauler by any stretch. Getting into the back seat is genuinely awkward, and loading anything bulky into the trunk takes some patience. So who is this actually for? Realistically, city and suburban drivers who can plug in every single night for their daily commute, and who want the gas engine sitting there purely as insurance, a psychological safety net for the occasional long road trip without the anxiety of hunting for a charger that might not exist when they need it most. It's not trying to be everything to everyone. It's trying to solve one very specific kind of anxiety.
Why range extenders are making a comeback. Here's where this story gets genuinely interesting, and where Mazda starts to look less like the underdog and more like the company that saw around a corner nobody else was looking at. The EV market is no longer growing evenly everywhere. Global sales still reached another record in 2025, but growth has become more dependent on subsidies, regional regulations, and charging access. Battery prices have fallen sharply, but large packs remain among the most expensive, heaviest, and most resource-intensive components in an EV. Raw material supply chains are volatile, and charging infrastructure is still patchy outside major cities and wealthy countries. The straight-line growth story has become much more complicated. Meanwhile, the expended range formula has become strategically important, especially in China, where Li Auto has built a genuinely massive, profitable business almost entirely around this exact idea. Drive electric day to day, extend the range with gas when you need it. And now the giants of the industry are following that same playbook. Hyundai is preparing true EREVs for 2027, while BYD has expanded electric-first plug-in hybrids that operate like range extenders in many situations, even though their engines can still drive the wheels directly. Pure EV sales are still growing globally, but the industry's product roadmaps are clearly becoming more flexible. But here's Mazda's real structural advantage in all of this. Other automakers can build compact piston engine generators, but they still have to manage the vibration, noise, and packaging compromises that come with them. Mazda has a different option. They possess decades of institutional knowledge in building rotary engines this small, this smooth, and this easy to tuck into a compact chassis. That experience doesn't give Mazda a monopoly on range extenders, but it does give the company a genuine, extremely hard-to-copy technical advantage, one built over more than 50 years, whether they originally intended it that way or not.
Mazda's 365 horsepower endgame. And this is where it stops being just a practical commuter solution and starts getting genuinely exciting for anyone who actually loves cars. Mazda's iconic SP concept previews what could become the company's next rotary-powered sports car built around a twin-rotor rotary EV system, producing a combined 370 PS, roughly 365 horsepower, or 272 kilowatts. Mazda has not confirmed a production date, but this isn't a compliance car idea built merely to satisfy emissions regulators. It's Mazda saying out loud that they still know how to build something you'd actually want to drive fast. The concept weighs 1,450 kilograms, remarkably light for anything with this much power and a battery on board. The engine sits low in the chassis, dropping the center of gravity and delivering an approximately 50-50 weight distribution front to rear, the kind of balance sports car engineers spend entire careers chasing and rarely fully achieve. But the bigger story here isn't really about one halo sports car, it's about what this engine can become over the next decade. Mazda says the rotary's compact design and fuel flexibility make it a promising generator for hydrogen, synthetic e-fuels, and other carbon-neutral fuels. That doesn't mean conversion is effortless or that piston engines can't use those fuels too, but Mazda has already spent decades developing the sealing, combustion, and thermal management knowledge needed to keep evolving the design. And the commitment is more than rhetoric. In 2024, Mazda re-established a dedicated rotary engine development group with 36 engineers focused on electrified powertrains, future regulations, and carbon-neutral fuels. This isn't a side project buried in a corner of the R&D budget. It's a genuine bet on the engine's second act, and possibly its most important one yet.
Big battery or rotary freedom? Here's the real takeaway. Mazda just demonstrated that the road to a greener future doesn't have to run through one giant battery pack. By rethinking the engineering from the ground up, they've found a way to blend the smooth, quiet drive of an EV with the freedom of a gas station on every corner. So here's the question I want you to sit with. Would you carry around a massive battery and hope the charging network shows up when you need it? Or would you take Mazda's freedom and accept paying a little more at the pump for it? Drop your answer in the comments. I genuinely want to know which side of this you're on, because the automakers themselves are clearly still arguing about it. And if you want to see where this rivalry goes next, because BYD and Hyundai aren't sitting still either, hit subscribe and turn on notifications. The next deep dive breaks down exactly how the competition is racing to catch up, and whether anyone can actually beat Mazda at its own game.